Intro to Exponents. So during this lesson, we'll be expanding and simplifying bases and exponents. We will learn the basic meaning of exponents, basic definitions associated with this unit, and how to expand and simplify an expression that has exponents. A power is a number that is expressed using an exponent. And a base, that is the number that is being multiplied or raised by an exponent. An exponent tells you how many times the base is used as a factor or how many times it is being multiplied. If we look at our description over here, you can see that here we have 2 raised to the 5th power. This entire thing is what we call a power. And the 2 is our base, and the 5 is our exponent. Notice that the 5 is raised up. It is raised, and that is what we call our exponent. So we would say this as 2 to the 5th power. Little side note, an exponent is a shortcut for showing repeated multiplication. Move this up. So an exponent is a shortcut for showing repeated multiplication. For each power, I want you to underline the base and circle the exponent. So what I will do is the first example for you, and then you can try the rest, and then check the answers afterwards. So if we look at 5 raised to the 2nd power, we're going to underline our base. Our base is 5, and we're going to circle our exponent. So our exponent is 2. And I'll do one more for you. Looking at 6 cubed, or 6 raised to the 3rd power, our base is 6, and our exponent is 3. Take about 30 seconds to go ahead and do the other 4 examples. Okay, looking at our next example, 10 to the 4th power, our base is 10, our exponent is 4. Our next example, our base is 7, and our exponent is 8. The next example, our base is the variable x, and our exponent is 5. And in our very last example, here we have two bases and two exponents. Our first base is y, our second base is m, and our first exponent is 5, and our second exponent is 3. Here, let's talk about reading and writing powers. So if we start on the left, we can see 3 with a 1 of an exponent, and we will read that as 3 to the first power, meaning that when we write this, we're only going to multiply 3 by itself once, because that's what our exponent tells us to do. And 3 times itself is simply 3, and that is why we only have one factor, and that factor is 3. Looking at our second example, we have 3 to the second power. We can also read that as 3 squared. And that tells us that we must multiply the base by itself twice. So you can see that our factors are 3 times 3. We're multiplying the base times itself twice. Then we have 3 to the third power, also known as 3 cubed. And that tells us that we must multiply 3 times itself 3 times. So that is why our factors are 3 times 3 times 3. 3 to the fourth power, or we can also say 3 to the fourth, tells us that we must multiply the base, which is 3, times itself 4 times. So we do 3 times 3 times 3 times 3. And we can do that for as ever large as our exponent may be. So that's why you can see at the very bottom we have 3 to the nth power, because that tells us that we can multiply our number 3 by whatever number that I decide to put here instead of n. So if I decided to write 3 to the 27th power, that would mean that I would write out 3 times 3 times 3 times 3 times 3 until I multiplied 3 times itself 27 times. I'm not going to write that. On this slide, I'd like you to match each verbal expression with its numerical expression. Now remember that a verbal expression means words. And a numerical expression, remember we have that word number in there, so we're going to match it with numbers. So looking at our first example, we have 8 to the second power. So we are going to have a base of 8 and a 2 as an exponent. And that takes us to option C. Notice again, we have 8 as our base to the second power, so that means 8 squared, or 8 to the second power, because 2 is our exponent. So take a bit, and I would like you to try the other ones. Now, look up there. It does say that choices may be used more than once, so that is a hint that a choice may be used more than once. Alright, so let's look at example 2. It says 8 cubed. We can also write that as 8 to the third power. 8 to the third power looks just like choice B. 8 to the fourth power So we're looking at for 8 as our base and 4 as our exponent. And that is choice A. And 8 squared. 8 squared, we're looking for 8 as our base and 2 as our exponent, because that is what squared means. It means to have an exponent of 2. So again, we're using choice C. Looking at our top example, you can see that I have 2 times 2 times 2 times 2 times 2. We have multiplied 2 by itself 5 times. So that is why I can combine all of this to look like 2 to the 5th power. Because again, exponents are a way of writing repeated multiplication. And 2 to the 5th power equals 32. In your calculators, you would put this as 2 and then press the little upside down caret button or the upside down V, and then you would press 5 and then the equal sign, and that would give you an answer of 32. I like to write each expression using exponents. So now you can see that we have different bases. We have a combination of -2 in parentheses, but then it switches and we have the bases of 3. The base of -2 is a factor 3 times, and the base of 3 is a factor 4 times. So I can combine all that together into one pretty little expression. And like I said, we have -2 times -2 times -2. We can rewrite that as -2 to the 3rd power. And then since we're multiplying, we bring over a multiplication sign, and we can combine this piece, our 3 times 3 times 3, as 3 to the 4th power. Okay? Let's look at example 2. We can have variables such as a and b or x and y to be used as bases as well. So we have, in example 2, we have a times b times b times a times b. We are going to rewrite this equation and put all of our a's in the front and all of our a's in the back, just so it's easier to count. So we can see that here is what it looks like in the beginning. In the second portion, what I have done is I have taken the 2 a's that I have and pushed them up front. And I have taken the 3 b's that I've had and I've pushed them to the back. So again, I have a being multiplied by itself twice, so I wrote a squared. And then I have b being multiplied by itself 3 times, so I wrote times b to the 3rd. I could also rewrite this even smaller, because it is multiplication, as a squared b to the 3rd. I could also rewrite this as a squared times b to the 3rd. All of those mean, all 3 of these, this expression, and the one directly below it, all mean the same thing. It's all telling you that you're multiplying a squared times b to the 3rd. So let's see how well that you have done with this. I would like you to try A, B, and C. I'll give you about 30 seconds to go ahead and give it a shot. Okay, let's take a look at letter A. We have 1/2 being multiplied by itself how many times? Let's go ahead and see. 1/2 being multiplied once, twice, 3 times, 4 times. So I can write this as 1/2, and I'm going to put it in parentheses just for good measure, raised to the 4th power because, again, I'm multiplying 1/2 times itself 4 times. Once, twice, 3 times, 4 times. Let's look at letter B. Letter B, we now have 2 separate bases. We have 4 and we have 5. So what I'm going to do right off the bat is write my 2 bases. And I'll write it in 2 different colors. I have 4 and I have 5. I'm multiplying 4 times itself 3 times, and I have 5 multiplying itself twice. So my final answer is going to be 4 to the 3rd, 5 squared. Again, if you would prefer, you could also write it as such. You could also write it either way. The first, the second, or the third way would be considered correct. Looking at our third example, again, we have 2 different bases. This time we're working with variables. We have our variables m, and we have our variables n. M is being multiplied by itself 3 times, and our variable n is being multiplied by itself twice. Okay? So in this example, I'm asking you to evaluate negative 2 to the 3rd raised to the 4th power. And we can see here in the example that we have taken negative 2 to the 3rd raised to the 4th power, and we've expanded it to look like negative 2 to the 3rd times negative 2 to the 3rd times negative 2 to the 3rd times negative 2 to the 3rd. When I put that in my calculator, or when I multiply everything straight across, when you multiply fractions, remember we're multiplying the numerator straight across. And 2 times 2 times 2 times 2 gives me 16. And then I'm going to multiply my denominator, the number on the bottom, times itself as well. And when I do that, 3 times 3 times 3 times 3 gives me 81. I'll do example D with you, and I'd like you to try the others as well. And actually, we're going to hold off for 1 second. Notice that when I expanded my example for negative 2 to the 3rd, that the parentheses followed. Okay? Each one of these has parentheses. So if your example has parentheses or does not have parentheses, that's how you need to put it in your calculator. So in your calculator, essentially when we expand the first example, you would do it as 4 times 4 times 4 times 4. In your calculator, you would do 4 raised. So you're going to find that little upside down V button. And then you're going to press 4 again, and then the equal sign. And you will get an answer. Now, the big difference here is when you do letter E, and you put that in your calculator, you need to be sure, and I know I talked about this when we talked about putting things into the calculator, about parentheses are super important, like super important, because you'll get the wrong answer if you don't do it. Putting the parentheses, so when you see them, into your calculator. So letter E, when we expand it, is going to look like negative 2 times negative 2 parentheses. Notice I'm using parentheses every time because my original problem has parentheses in it. And because I'm going to go over, I'll put this back here. Okay, super important that you put that exact thing in your calculator. Or if you put it in your calculator, you're going to put it in your calculator like this. You're going to do parentheses, negative, 2, close parentheses, upside down V, 6, equal sign. Because if you put it in your calculator without the parentheses, you're going to get a different answer. Go ahead, try it. You'll see that you get a completely different answer. Okay? So give me an answer for D, find me the answer for E, and try letter F on your own. When you put 4 raised to the 4th power in your calculator, you're going to get an answer of 256. When you put -2 in your calculator and you raise it to the 6th power, you're going to get an answer of positive 64. If you put that in your calculator and you did not get positive 64, you most likely got negative 64, and that answer is wrong. I know, as trivial as it may sound, it's still wrong. Okay? 1/5 to the 3rd power expanded looks like 1/5 times 1/5 times 1/5. When I put that in my calculator, again, parentheses, 1/5, upside down V button, 3 equals, your final answer will be 1/125. These are practice problems, so these 6 problems and the 6 problems on the next slide are going to be your homework problems, alright? Please refer back to the beginning of the video where you see these problems and use those as examples if you are confused. So I'll let the music play. If you don't want to hear the music, then hit pause and go ahead and do the problems on your own. Otherwise, feel free to listen to the music.